With the power of a product, we see parentheses, and when we see parentheses, we immediately think of distributive property. And so with the power of a product, we are going to take the exponent that is outside of the parentheses and distribute it to all of the bases inside of the parentheses. So for example, here the m is on the outside. It is going to get distributed to the a as well as the b. So that turns into a, the power of m, times b, the power of m. And that's our final answer. So if we look at some of these examples, we have in parentheses x and then y to the power of 2. And then outside of the parentheses, we have this 5. That 5 is going to go to the x as well as to the y. Since that y already has a power of 2, it turns into y to the power of 2 times 5. And then we have x to the power of 2. So that provides us with that x to the power of 5 and y to the power of 10. To the right, we also have another example. This has a 5 outside of the parentheses. That 5 is going to go to this negative 2 base, the x, as well as the y to the power of 3. So if you notice, when we distribute the exponent of 5 to negative 2, we put the negative 2 in parentheses because we are having that exponent for both the negative and the 2 at the same time, not just the 2 by itself. When we evaluate that with our calculator, that provides us with negative 32 as the simplified version of negative 2 to the power of 5. We have x to the power of 5, and then y to the power of 15, because 3 times 5 equals 15. So let's practice this with some examples. First, we have parentheses a to the power of 1. Again, you can imagine that has an invisible 1 on it. B to the power of 3. And then there is a 5 on the outside. That 5 is going to get distributed to the a as well as the b. So a to the power of 1 times 5 and b to the power of 3 times 5. 1 times 5 is still 5, so a to the power of 5, and then b to the power of 15, because 3 times 5 is 15. If we look to the right, we have 5, x to the power of 2, y to the power of 1. We have a 2 on the outside. That is going to go to all three pieces. It's going to go to the 5, to the x, and to the y. So we have 5 to the power of 2, x to the power of 2 times 2, since the x already had a 2, and then y to the power of 2. 5 to the power of 2, or 5 squared, is 25. X to the power of 4, y to the power of 2 as our final answer. And then for our last examples, these are a little more complicated. These are going to use our negative exponent rules as well as our power of a product rules. So we're going to combine some of these skills together. So the first thing I notice is I have a negative exponent, and there's a few ways I can attack this. I could go ahead and distribute that negative 3 to all of the pieces inside of the parentheses, or I could say the entire set of parentheses, the 2, a, and b to the power of 3, have that negative exponent of 3. So the entire thing is going to move downstairs. So on top, I have a large 1. And then underneath, I have 2a, b to the power of 3, close parentheses, and that negative 3 turns into a positive 3 once it moves downstairs. Now I can distribute that 3 to the 2, to the a, and to the b. When we do that, we have 1 over 2 to the power of 3, a to the power of 3, and b to the power of 3 times 3. When we simplify this for our final answer, 2 to the power of 3, you can use your calculator, is 8. A to the power of 3, and then b to the power of 9, because 3 times 3 gives us 9. Now our last example here, again, there's more than one way we can attack this. For this one, we are going to look at distributing the negative exponent into both sets of parentheses. So we have that -4 exponent is going to go to p as well as r to the power of 2. So we have p -4 and r to the power of 2 times -4 times p to the power of -3 as we distribute that -3 to the p, and that -3 is also going to go to r to the power of -2. So r -2 times -3. And we're going to go ahead and simplify some of these, the multiplication of exponents, to help us determine if these are still negative exponents or if they turn into positive exponents. So we have p to the -4, r to the power of 2 times -4 is -8, times p to the -3, and r, -2 times -3 is a positive 6. So now I want to group the like bases together. So we have p to the -4 and p to the -3. And then we have r to the -8 and r to the power of 6. So we're going to actually use the product of powers rule, which tells us if we are multiplying two of the same base together, we are going to add together their exponents. So we have p to the -4 plus -3. And then for the r's, we have r to the -8 plus 6. And then when we simplify this, we have p to the -7 times r to a -2. Since both of these have a negative exponent, they're both going to get moved downstairs, so into the bottom of a fraction. So we have a big 1 on top, and then we have p to the power of 7 and r to the power of 2. So once these move into the downstairs of the fraction, the exponents are no longer negative.